G'day everybody, doing some more maths. Let's get into it. Up to question 12 of the HSC. Thanks, little Ted. Alright, welcome back. Up to question 12 of those HSC questions. I've written it on a whiteboard. I'm having a crack at home this time. This was a question that we were finding the shaded region, I think, in here. I've written it all up. First part says really to find the x-coordinate of A, x-coordinate of B. Before we get into it, remember that the shaded, the function here at the top, which I think was sine x, that's sine x, it sits fully above this function here, which was root 3 cos x. All right, so now when we go ahead and integrate, we've got the same scenarios we've had. Top function fully sits above the bottom function, the cos x, so sine sits above cos. So when we go to integrate, we can go ahead and do the thing of top function sine x minus root 3 cos x. But the first part does say to solve this equation here, root 3 cos x equals sine x. And what we're going to do is find the x-coordinates of x-coordinates for A, x-coordinates for B. There's a line up there. Now I've rewritten this the other way around. Why did I do that? I did that because sine on cos equals tan. So dividing by cos over here, dividing cos over there. Sine divided by cos is tan x. Tan x equals root 3. Inverse tan, arctan of root 3 is 60 degrees, if you're in degrees, or pi on 3 if you're in radians. But paying attention to the fact that it is positive. It's positive. All right, so the x-coordinate. So for sort of finalising that answer, x-coordinate at A, x equals pi on 3. Right, if we move over to looking at the coordinate for B, remember we've noted here that x is positive. All right, now if remember our little quadrant here, they're all positive, sine's positive, tan is positive in the first quadrant and the third quadrant. So if we knew it was 60 degrees up here, 60 degrees down here, gives us 60 and 180, that 180 and the 60 is 240. Or chuck that into the calculator, the 240 and the 180 is 4 pi on 3. We'll clear that off and we'll have a go at finding the area under the curve. Okay, continuing on. Part 2. Let's have a crack. I'll pass over to Mr. De Beer. Mr. De Beer, you're up. Thank you, Hippo. Alright, same as we've just done. Went through part 1. Part 1 gave us coordinates for XA. Pi on 3 or 60 degrees. Plus x-coordinate for B, 4 pi on 3 or 240 degrees. And again, we wanted to find the area under the curve, top function minus the bottom function, or sine x minus root 3 cos x. So that's what I've done here, sine x minus root 3 cos x between pi on 3 or 4 pi on 3. You can, of course, stick to degrees if you're more confident with that, more happy to use that in your calculator. I'm going to stick with radians for now. Integral of sine. Integral of sine is minus cos. It's minus cos. Integral of cos is sine, but there's a minus on there, so that stays there. Minus root 3. Integral of cos is sine, and it runs between 4 pi on 3 and pi on 3, given by our points A and B. Right, if you haven't already seen this, this is where actually probably the most difficult part, funnily enough, is. So all the numbering in here, all these numbers, you get muddled up with calculations because there's numbers and cos and brackets flying all over the place. And of all the things to do, this seems to be the hardest thing to do. So getting this right clearly is the step to get right. And to be honest, I've stuffed up so many times with all these numbers and trying to get it right. I've pre-written it so to avoid that. Negative cos using the first value, top value of 4 pi on 3. Chucking that into my calculator, you might have used 240 degrees, end up getting a value of a half. Just practice that until you get it right. There's the minus sign, it's root 3 sine 4.3, chucking all that into a calculator. I ended up getting minus 1.5, so that minus ended up becoming plus. There's a half, minus plus 1.5, gave me the value of 2. Doing the same with the lower value now of pi on 3. Putting this back into, substituting back in, so I've got minus cos pi on 3. Chuck that into a calculator. End up with negative a half. Do the same with the sine, negative 1.5. So this is minus a half minus 1.5, so that's -2, but this minus is there. There's the value of minus. So minus again means plus 2 gives me 4 square units. All right, that's question 12 done. Okay, continuing on, I think I'm up to question 13. Second A to Mr. Such and Such. He's not doing much. It's bloody hard to balance this fella. There we go. Right, let's have a look at question 13. Anyway, this is again from those HSC questions. Same deal, again paying attention that, if you haven't noticed, these questions seem to double up a lot, just in terms of the way they're set out. We've got a top function, above the bottom function. Oh, pay attention to the fact that when they've written it on the question paper, they wrote this function here, the information about this function, x squared minus 3x, they actually wrote it up here, and they wrote this bit of it down here. It's attached to the curve, but I think it's a little bit devious, a bit sneaky, when they go ahead and write the value of the function on the curve, but they sort of put it in the wrong spot. So, you know, it'd be kind of accepted that you make the mistake of going, well, this is the top function and this is the bottom function, but they actually mix those up by just simply looking at the graph. All right, so pay really close attention to which curve is the top function and what its, you know, what's its graph is, what's its value is, before writing that stuff down. Anyway, before we get onto that, same as the other ones as well, it's asked us to find the x-coordinate for this value here. So when we integrate between these areas, we've got that value at the end. Paying attention, that's probably going to be a 0 out to some variable here. It's polynomials, parabolas, so it should be expected to find a nice whole number. All right, x-coordinate. X-coordinate A, we've paid attention that these intersect. So at that point there, those two curves are the same thing. So I've let the x squared minus 3x equal 5x minus x squared. Putting the x squared to that side, 2x squared minus 3x equals 5x, take it 5x. 2x squared minus 8x equals 0. Factorising, I've got x equals 0 out the front here. I've got if x was 4, so I've got a solution of x equals 0 and 4, and that checks out on the graph as well. Our values are in between 0 and 4. All right, so if we now go on to the area under the curve, don't pay attention to that just yet. Area under the curve is the top function minus the bottom function. Now I have made this point by including our little friend over here. It is the whole function, the whole thing, minus the other thing. Now if we don't write it like that, and we go ahead and write it like this, here is the top function minus the bottom one, but if we were to simplify all that down, we're going to get 5x minus the 3x is 2x, minus x squared minus x squared is minus 2x squared. Bow, bow. Wrong. All right, pay attention. It's the whole thing minus this thing. So these are in brackets, so minus becomes plus. I don't even like saying that. It annoys me. All right, so be warned that it's the top function minus the whole thing completely. So put it in brackets. The setting up thing is so important. Josh Spence. Setting out is so important for doing this stuff right. 5x minus x squared minus the x squared minus becomes plus. Putting all that together, minus 2x squared, 5x plus 3x is 8x. Not this ugly machine up here. Integrating now, minus the 2x squared integrated 2x cubed on 3, so minus there. 8x squared on the 2, so 8 on the 2 becomes 4. So really simple integration in the end. Integrating all that stuff down, paying attention again to the fact that we've got a 0 here. So putting that into our integration here ends up being 0, so we're not even going to worry about that. So it's 0, yep, so we don't worry about this stuff at the end. So I really have just got to concentrate on doing this bit right. Putting brackets around is a great way to not stuff it up. Don't put brackets in, it gets ugly, especially with negatives. So putting in the brackets and working that individual is a great idea. Do enough of these questions as practice and you should do much better. All right, putting all that together, 64 on 3 squared units. All right, and it's not even saying exact value, so you could leave it as a decimal, but we've gone to 64 on 3. All right, keep practicing. Hope you're doing well. See you.